It is the force of friction that enables us to walk. Let's look into this. Now the mass of this shoe is about 800 grams. That's about 0.8 kilograms. So the gravitational force acting on the shoe is 8 newtons. Now shoes are made to provide friction so that we can walk. How can we measure the friction provided by this shoe alone? Well, we can use a Newton meter, otherwise a force meter, to measure the force needed for the shoe to start sliding along. Now let's see. In this case, there's 2 newtons, there's no sliding, 3 newtons, there's 4 newtons, and it begins to slide at 4 newtons. So we can say that the friction force provided against the sliding is 4 newtons. As soon as we go over 4 newtons, then it begins to slip. Now, if we had different surfaces, of course, if the surfaces were smoother, there will be less friction, and if they were rougher, there will be more friction. What other factors affect friction? Well, besides surface smoothness, we also have the normal reaction force, and that is the force provided by the surface in contact that acts perpendicular to it, and in this case, vertically upwards. So let's increase the normal force by adding some weights to the shoe. In this case, I will add 300 grams, so that's about 3 newtons. And let's see if the friction force remains the same. So I increase it, 2 newtons, we're now past 4 newtons, 5 newtons, 6 newtons, and okay, so we're about 7.5 newtons. The shoe began to slip at 7.5 newtons. So it now increased by 3.5 newtons. Well, if we increase further the normal force, then the friction force should also increase. So let's see now, we're 6, we're past 7, there's still no slipping, we're 8, no slipping, 9, there's no slipping, we've gone at about 10 to begin slipping. And if you notice, the shoe has actually lifted up a bit there, so that played a role. Now, does the angle that I pull at make a difference? Yes, because if I pull it at an upward angle like this, then it's easier to get the shoe moving because I'm actually lifting the shoe up as well, and therefore reducing the normal reaction force. Whereas if I pull it at a downward angle, it'll be more difficult to get the shoe moving. You see, we've gone past 10 newtons and it's still not there. And that's because my downward acting force has a downward component that actually adds to the weight and therefore the normal reaction, to the push down on the table and therefore the normal reaction.